What if we told you that most of the universe is missing? Not the stars, not the planets, not even the black holes, something far more mysterious. It's called dark matter, and it makes up around 85% of the total mass in the universe, yet we can't see it, touch it, or even detect it directly. So how do we know it's there? And why is dark matter so important? Join us as we explore one of the greatest unsolved mysteries in physics, the search for dark matter. Let's start with the basics. Dark matter is an invisible substance that doesn't emit, absorb, or reflect light. Unlike the matter that makes up you, me, and everything we see around us, dark matter interacts with regular matter only through gravity. We know it exists because its gravitational effects can be observed in the way galaxies move and behave. One of the first pieces of evidence for dark matter came in the 1930s when astronomer Fritz Zwicky noticed something strange about the Coma galaxy cluster. The galaxies were moving so fast that they should have flown apart, but they didn't. He hypothesized that some kind of invisible mass was holding them together, what he called dark matter. In the decades since Zwicky's discovery, more evidence has piled up. For example, in the 1970s, astronomer Vera Rubin studied the rotation curves of galaxies. According to Newtonian physics, stars farther from the center of a galaxy should move slower than those near the center, but Rubin found that stars on the outskirts of galaxies moved just as fast as those closer to the center. Something unseen was providing the extra gravitational pull, once again, pointing to dark matter. But the strongest evidence comes from cosmic lensing. This phenomenon occurs when light from distant galaxies is bent by the gravitational field of a massive object, like a galaxy cluster. The amount of bending tells us how much mass is present, and in many cases the mass calculated from lensing is far greater than what's visible. So what is dark matter? That's the billion-dollar question. Scientists have proposed several ideas, but none have been proven yet. One popular theory is that dark matter could be made up of particles called WIMPs, or weakly interacting massive particles. These particles would interact with regular matter only through gravity and the weak nuclear force, making them incredibly difficult to detect. Other candidates include axions, which are hypothetical particles that are even lighter than WIMPs. They could solve both the dark matter mystery and a problem in quantum physics known as the strong CP problem. There's also the idea of sterile neutrinos, a type of neutrino that doesn't interact with matter through the weak nuclear force like regular neutrinos. To find dark matter, scientists have built enormous detectors deep underground to avoid interference from cosmic rays and other particles. One such experiment is the Lux-Zeppelin detector, located more than a kilometer underground in a former gold mine in South Dakota. It uses xenon gas to detect the faint signals that would indicate the presence of dark matter particles. But the search doesn't stop on Earth. Space-based experiments like the Alpha Magnetic Spectrometer on the International Space Station are also trying to detect dark matter particles in space, looking for any hint of their existence through cosmic rays. Despite all of this, we've yet to directly detect dark matter. This has led some scientists to question whether dark matter exists at all. One alternative theory is modified Newtonian dynamics, or MOND, which suggests that we might need to change our understanding of gravity rather than introduce a new form of matter. But so far, dark matter remains the most convincing explanation for the strange behavior we see in galaxies. So why is dark matter so important? Understanding dark matter could unlock new physics beyond the standard model, the framework that currently explains the known particles and forces. Without dark matter, we wouldn't be able to explain how galaxies form, how clusters of galaxies stick together, or even how the universe evolved after the Big Bang. Some scientists even believe that if we could understand dark matter, it might lead to breakthroughs in our understanding of gravity, quantum mechanics, and the fate of the universe itself. Could dark matter help solve the mystery of dark energy, the force driving the acceleration of the universe's expansion? Only time and more research will tell. The search for dark matter continues to be one of the most exciting and challenging quests in modern physics. With every new experiment, we get one step closer to uncovering the invisible mass that holds our universe together. Whether it's WIMPs, axions, or something even stranger, one thing is certain: finding dark matter will change our understanding of the universe forever. Thanks for joining us on this journey through the cosmos. If you enjoyed this video, give it a thumbs up and subscribe to Deep Dive Science for more content on the mysteries of the universe. Let us know in the comments what other cosmic questions you'd like us to explore next.